This video is going to cover the topic of exponents. Be sure the date and topic is at the top of your page. The essential question that also needs to be on your page is, how do we show the number of times a factor is used to produce a whole number? Let's start by quickly reviewing the concept of prime factorization. And we're going to review it with the number 60. So we'll use 60 for this. And remember, what we're looking for are the prime numbers that build together to create the number 60. So I'm going to use a little factor tree, and I'm going to think of the pairs that I can use to make 60. And I know 2 times 30 makes 60, and that is prime already right there, 2. But 30 isn't prime, so I'm going to keep going. I know 2 times 15 multiplies to make 30. 2 is prime, but 15 is not. And lastly, I know that 3 times 5 makes 15. And so I've hit the end of every branch ending with a prime number. So now I know that the prime factorization of 60 is 2 times 2 times 3 times 5. Those numbers multiply to make a product of 60, and they are all prime numbers. Now let's connect this example to the term exponent. But first, let me define what an exponent is. An exponent is a type of notation, right? So it is something that indicates something for us, and it's a small raised number that tells us how many times a particular factor is used in a multiplication problem. So I'm going to look back at what I had up here, where I said that 60 was equal to 2 times 2 times 3 times 5. Those are all of our primes. And I'm going to go back and look and notice that the 2 appears twice. So what that means is that I can rewrite this by saying that 2 appears twice, but then there's still a 3 and there's still a 5. This 2 with the little 2 in the corner indicates that we are doing 2 times 2. I'm going to demonstrate this again with another factor tree, this time using 100. So I'm going to say 10 times 10 makes 100. 2 times 5 makes 10. Oh, those are prime. And 2 times 5 makes the other 10. And those are also prime. So I know that the prime factorization of 100 is 2 times 5 times 2 times 5. But I want to write this with exponents. So I'm going to look through my list, and I'm going to notice that 2 is being multiplied twice. So I can rewrite this by saying 2 to the second power. You'll often hear me say to the second power times, let's see how many 5s there are. Oh, there's also 2 5s. So we can write 5 to the second power. These two equations are equivalent. They mean the same thing. And just so you're familiar with how you might hear someone say this, they might say 2 squared if there's a 2 in the corner, or they might say 2 to the second power. Those mean the same thing, and that's indicating that there is an exponent there with the number 2. So I went ahead and did a factor tree for 48, and I know that the prime factorization of 48 is 3 times 2 times 2 times 2 times 2, because those are all the prime numbers at the end of my factor tree. So I'm going to go ahead and look through and see another way to write this. And I think there's only 1 3, but I see 1, 2, 3, 4 2s. So I'm going to say that 48 could also be written as the product of 3 times 2. And this time I need 1, 2, 3, 4 to the power of 4. And again, that would be described by someone as the power of 4. And that means that 2 is being multiplied, not added, not subtracted, not divided, but multiplied 4 times. 2 times 2 times 2 times 2. And then, of course, times 3. In the last example, we had something that I said was 2 to the power of 4. So I just want to label the parts of this. So the 2 is the base. That's the number that's getting repeated. The 4 is our exponent or power, and it tells us how many times. So now I'm going to kind of look at this from the other side. So if I see something written here with a base of 4 and an exponent of 3, 4 to the power of 3, I want to know what that means, right? A lot of people think it means 12. It does not equal 12, right? It is not 4 times 3. What this means is that we're taking our base, 4, and we need it 3 times. So 4, 4, 4. But this is the product of all of these 4s. Those exponents are telling us to multiply 4 times 4 times 4. And if I do that, I can do that in parts here, right? 4 times 4 is 16, times another 4 is 64. That means 4 to the third power is 64, not 12. Very different answers, right? Because multiplication grows much faster than addition. 4 times 4 times 4 is 64. Let's try each of these. So I have 2 to the fourth power and 5 to the third power. Take a moment and write down what you think would be the answers for each of these. Pause the video, and when you're ready to check, go ahead and unpause. Let's see how we did. So remember that this is telling us that we're using our base of 2 4 times, and we're multiplying each of those 2's together. So 2 times 2 is 4, times another 2 is 8, times the last 2 is 16. So 2 to the fourth power is actually 16. How'd you do? Did you get that? Or did you maybe get 8? If you got 8, you might have made that mistake we talked about on the previous page. This one would be 5 3 times, and we would want to multiply them together. So 5 times 5 is 25, times that other 5 gets us 125. 5 to the third power grows really quickly, ends up as 125. The Your Turn today has 2 parts. The first one, I want you to take the number 40, create a factor tree, and record the prime factorization using exponents. And on the other side, I want you to determine the value of 3 to the power of 3. So you'll take care of both of those as a practice, and we'll be able to kind of talk about what we saw, what we noticed, and what mistakes we might have made. So remember that the essential question for the video was, how do we show the number of times a factor is used to produce a number? And so we'll see that in our factor trees. We'll practice writing the number of times a factor is used using exponents. And of course, going in the other direction, we'll be able to then manipulate and use exponents to create a number.